find intercepts like you guys said, okay? X-intercept and Y-intercept, we just plug in 0 for the other variable. But in these equations, it's harder to solve because they're logarithmic and exponential. So I told you on your test, you're going to have to graph a couple of exponential equations. You're going to have to graph a couple of log equations. And then there's going to be a couple of problems where it asks you to find intercepts like this of either exponential or log equations themselves, okay? So specifically, both x-intercept and y-intercept. So the work for the x-intercept is going to be different than the work for the y-intercept because there's a different procedure for each of those. You guys just told me to find the x-intercept, you plug in 0 for y. To find the y-intercept, you plug in 0 for x. So these are two different procedures. So to find the x-intercept, I plug in 0 for y. Remember in this equation, your f of x is like your y. So if I replace that with 0, then this equation looks like 0 is equal to negative log base 1/2 of x minus 2 plus 3. Okay? So to solve a log equation, the first thing you guys need to do is you need to get the log part of the equation, everything that's contained in the logarithm, alone. So what are the steps I'm going to have to do to isolate the log part of the equation? What am I going to do to get the piece that I put in a box alone? Subtract a 3. Good. So that will get rid of this part. And then what about for this? Divide by -1. So I'm going to go through those two steps. Then the log will be alone. And then it gets like I have to actually think about how logs and exponents work. So I'll subtract 3 from both sides. And then I'll divide by -1 to cancel out the negative. So this is why we did some of those review worksheets at the beginning. How do we solve an equation like this? So once we have a log equation where it has just one logarithm in it and we get the log alone, what do we do at this point to try to finish solving this equation? Good. Okay, so when you're stuck in a log equation, and you can't do anything else with it as far as logs go, your goal should be to try and rewrite it in exponent form. Okay, and same thing, when you're stuck in an exponent equation and you can't solve it with exponents, you try to rewrite it with logarithms. Okay, so at this point, we try to change this into exponential form. So remember, the base is still the base. So 1/2 is the base. And then the other two parts you have are the 3 and the x minus 2. One of those is the exponent, and one of them goes on the other side of the equation. Which part of this log equation represents the exponent, the 3 or the x minus 2? The 3, okay? And this is why this is so handy, because now x is no longer trapped inside anything. It's right there, okay? So 1/2 to the third power would be 1/8. And then my final step to figure out what x would be to add 2 to both sides. And then I get that x is equal to, 2 1/8, okay? You can write it in a different format if you want. So that means my x-intercept is 2 1/8 is the x-coordinate when 0 is the y-coordinate. That's what I just figured out, okay? Put this on this side. All right, so to find the y-intercept, okay, what do? You guys told me earlier. Plug in 0 for x. So the y-intercept is going to be 0 for x and some number for y, and our goal is to figure out that value for y. So when we plug in 0 for x, the y is in the equation. We have log base 1/2. We plug in 0 for x. So basically, y is already alone. And there's just a bunch of stuff for you to calculate on the right-hand side of the equation to figure out the y-intercept. So in order to figure out the y-intercept, you would have to calculate all of this. Okay? Yes? Oh, thank you. Okay. Are we good with this? Okay. So let's look at what that looks like. First, simplify what's inside the logarithm so you actually know what you're taking the log of. So 0 minus 2 would give me -2. So what I would do is I would figure out what number this is, And then to get y, I'm going to do the opposite of whatever number that is plus 3. Okay? But again, this is why we did some of the review. What is log base anything of a negative number? Impossible, right? So this is actually kind of good for you if you know that, because what does that mean you get to do at this point? Stop working. Okay? And what does that mean about the y-intercept? It doesn't exist. Okay? It doesn't have one. So you can write none, no y-intercept, whatever you want to write. So this graph doesn't cross the y-axis at all. Okay? Yeah, so that does, it's not where the asymptote is necessarily in this case, because when you think about it, this one would be shifted 2 to the right. So what happened is the asymptote's shifted to positive 2, and then the whole graph is on one side of positive 2, and so nothing touches the y-axis. It's empty on that spot. So it'd be like, here's your asymptote, and your whole graph is over here like this or something. So that's why nothing has a y-intercept. So if you understand the graphs well, it'll make sense when certain things don't have x or y-intercepts. Okay? Is this okay with everybody using a log example? Okay? So the procedure is not going to change. It's just that the solving's a little more difficult, which is why we spent all that time at the beginning reviewing how to solve log and exponential equations to try and make them make sense. So right here, this is not calculatable. It's impossible. You can't take log base anything of a negative number. So at that point, I know that that's undefined and I can't calculate it, so there must be no y-intercept. Okay? All right. So this one is very similar. We'll let you guys work on that later when you're reviewing. Let's do an exponential one. Okay? So this one is an exponential function. And so again, the x-intercept requires one procedure instead of work, and then the y-intercept will require another. Okay? So the x-intercept, to get it, remember, x plus 1. You're looking for an x value, and 0 is the y value. So I'm going to take the equation and plug in 0 where y would be. So solving for x tends to be a little harder, because if you're plugging in stuff for x, y is already alone, and you just have to do a bunch of calculations. If you're plugging in something for y and solving for x, in these equations, x is always in a difficult spot, right? In the last one that we looked at, x was stuck inside the logarithm. That's what made the solving part get difficult down here, okay? In this one that we're looking at, x is stuck in the exponent. So again, you're going to have to get this piece alone before you can do anything else to solve for x. Okay? So that means I'm going to subtract 2. And divide by negative 3. Notice I never multiplied together the negative 3 and the 2. The 2 has an exponent on it that doesn't exist on the negative 3. The negative 3 can't just jump in there like it's part of the exponent also. Okay? All right, so at this point, to solve an exponential problem, you guys had 2 choices. Choice number 1, you can make the bases the same. Okay? An example of that would be a problem where these could both be powers of 2, like if 2 to the x plus 1 was set equal to 8. Okay? Because you could change the 8 to be 2 to the third, and then once they both had 2's, you could just set the exponents equal. Okay? Is that possible here? No. Okay? So what did we do when that wasn't possible? When we couldn't solve the exponent equation using exponents, what are we going to use instead? Logs, okay? So remember that meant we just put a log on both sides. So log of 2/3 on the left and the log of 2 to the x plus 1 on the right. And the reason that was helpful is because logs had this property that like releases the exponent from that power. This becomes x plus 1 times log of 2. Okay? So remember, log of 2 is a number. You could literally push log of 2 on your calculator and press enter, and it'll give you some decimal number. So this is x plus 1 just being multiplied by some number. And on this side, you have log of 2 divided by 3. Again, you could put that into the calculator like that, and it would give you some number also. So this is some weird decimal number equals x plus 1 times another weird decimal number, okay? We don't have a calculator, which means we're not going to find out what these decimal numbers are. We're just going to add, subtract, multiply, or divide by them like we normally would to move them around to eventually get x alone, okay? So if my goal right now is to get x alone, first I need this piece alone so that x can be alone. So the first thing I'm going to do is divide both sides by log of 2 so that that will cancel out, okay? And it's okay that you have something crazy looking on this side. It's fine, okay? So at this point, we have log of 2/3 divided by log of 2 equals x plus 1. Okay? And then what's the last thing I have to do to get x alone? Minus 1. Okay? So this minus 1 on the left side means there's this big old fraction that we can't calculate because we're not using a calculator. And then after it, it just says minus 1. Okay? And that's what I have for x. That's my x-intercept. It's ugly. If you put it into the calculator, you'd be able to get a decimal. We're just not doing that. Okay? So you can leave it just like that on the test. Is that all right with everybody? So same idea for x-intercept. 0 goes in for y. When it's exponential, get it alone. If you can make the same base, great. If you can't, remember, if you're stuck in an exponential equation, try logs. If you're stuck in a log equation, try transforming it into exponents. Okay? They kind of work to help each other. All right, so y-intercept of this one, 0 in for x. What's going to be the y-intercept? So I'm just going to go ahead and plug 0 in for x and then make sure I do the correct order of operations. So with order of operations, you need to do exponents before you do simple things like multiplication, division, addition, and subtraction. So you really need to calculate this power before you do anything else. So this is going to be negative 3 times whatever that power turns out to be, and then plus 2. Okay? So this power is 2 to the power of 0 plus 1. 0 plus 1 is just 1. So 2 to the first power is just 2. Okay? So that's negative 6 plus 2, which would be negative 4. Okay? So my y-intercept is that point on the y-axis at negative 4. Is everybody okay with finding x and y-intercepts? Hopefully you see why we spent all that time doing those solving things at the beginning, because they're going to help you do this here. Okay? So your test is going to